So yeah, so thanks for inviting me. So I'll speak about what we are doing in the Emobility and how we see the challenges and opportunities. So this is a presentation by myself and many of my colleagues. So of course, as you know, we are driving this zero emission reality, right? As you know, transportation is creating 24% of global CO2 emissions. And of course, we are really trying to help reduce this part of the nuisance, you know, that we have with the carbon emissions. So in terms of the penetration, as this is the global penetration outlook. So as you see, starting some years ago, very slowly. So it's really picking up, especially with the regulations now, and so on. And this is what we believe. While it has been then early adoption, especially in the US and Europe, to some extent Japan and China, as you know, in any case, has really been growing acceptance with the arrival of the fleets and also how to make revenues and so on. So it's going just beyond the subsidized nature of the business to really now what we believe in the next few years and so on, it would really be mass adoption. And we already see some of these trends happening in many of the countries, where we believe, you know, this penetration level by 2030 would be above, you know, 50%. But let's see how it evolves. But these are still some projections where the numbers of, you know, the vehicles that will be sold that would be electric, you know, would be into 30s or 40s millions. So what does it mean for the grid? As you see, what we need is really current, right? So we have some standards based voltages, could be 400 to 480 volts, 200 to 240 volts, that are, you know, that feeds these chargers. But then you really need the current, you know, to allow this very fast charging, which means that as you have bigger batteries and you want these batteries to be charged first, so you really need this current. And the way it is done today, you know, so the people are playing with the medium voltage side, as well as the low voltage side. So this is the space, you know, which is really more pressed. So on the transmission side and so on, this is not an issue. Also on the distribution side, but is really, you know, when these chargers are connected through transformers to medium voltage points, especially as you are looking at above 100, 150, few hundred kW per charger or even per site. So this is, you know, where the main challenge is really on the distribution systems and the accessories attached to that. Of course, if the medium voltage solution is a constraint, so we don't, let's say it's difficult to upgrade it, or we have to live with whatever nodes we are available, then it really becomes a low voltage distribution type of challenge, which means that you have the batteries that come to play. You may have to over-dimension some of these transformers, but this is, you know, where then where the challenge, at least in the short term, is now being moved, you know, from a medium voltage side to really low voltage side with the arrival of batteries, some fuel cells, and the likes. Okay, this is just one example for the situation in Germany, where, you know, it is assumed, okay, for a certain, you know, type of load and certain type of, you know, possibilities for the investment and so on, what it would look like. So as you see here, really, it is reduction of peak loads. So how to handle those peak loads in the case of EV charging. Then of course the grid that is needed to support it, and also how the load can be managed. And of course, one of the hope here is that the electric mobility will also help co-finance the extension of the grid, right? As the grid expands to allow EV charging, then this is how, you know, this some part of the financing, as we see in the US now with the recent infrastructure bill. So e-mobility is also leading the upgrade, you know, of some parts of the grid. And of course, the last thing is that the load management, so that you're not blowing up the fuse, and you have your transformer can supply the different loads, are really, you know, being managed at an acceptable level, you know, without really causing disadvantage, you know, for the users. Okay, so what does it mean for the load management? So this is just one case where it is an ABB product called the EV site system, EVSS 100. Okay, this is for a case of a bus depot where you have 10 buses, and, you know, then and then to be able to provide this peak power that is needed, you have a certain battery. And then you have a certain number of chargers. Of course, this is an arbitrary case, and as you see here, based on what time you need to charge these buses with different type of different chargers. So it means, as you see here, the power really can go up to 600 kW. In this particular case, the available grid connection in this case was half a megawatt. And then, of course, you have to somehow play with the peak consumption target, and with the help of the batteries, you can play around with it, so that your peak consumption target are within the required grid connection. And this is what we see more and more happening, with the arrival of batteries, and especially as people go from individual use to really, fleet concepts. So what does it mean? It means that the first thing, okay, when you have multiple chargers on a site, you don't want to blow the fuse. This is the minimum requirement, where a lot of these cars or logistic trucks or buses are really mission critical. So you don't want to blow up your transformer and so on by overdrawing the current. So this is how you're managing the first thing, shown in the pink side on the left. Then we really go to the peak shaving, which is still in one direction. So we are, with the help of the batteries, we are really taking care of the peak shaving, as was shown here in the previous arbitrary example. Then, of course, you can move to the site energy optimization, where not only the charging part, but also whatever else assets you have in at your site, solar, wind, even the including internal building management and the substation. So you can really go from a charger operation, to really a site operation, where you're really optimizing the energy consumption by the site and the availability of the supply and so on. And then, of course, when you have multiple of these charging sites, you can go through a gateway and really have your cloud-based monitoring and services that are provided, which in turn are also leveraging the weather forecast. They have more predictive load profiles. You are able to schedule the fleets, perform energy trading if it is allowed, and so on. Plus, the new thing that is coming out is really the bidirectional part, where you really will go from one direction of managing the energy that is needed by these guys here, to really be able to also use them as an asset. So they could also store energy and provide back to the grid or to the site as is needed. So this is the new thing, the bidirectional. Where bidirectional could be bidirectional from a car to a site, to a batteries, whatever, but could also be bidirectional going from your cars back to all the way to the grid, which is called the V2G possibility. Okay, and as you see here, so there's so many different assets here, not only the chargers but the batteries and the buildings and whatever. So what it really means, that not only the power layer that is important, but also the digital interface is really important. So since these will be solutions and products supplied from different vendors and different, and used by different customers at different stages of this this value chain. So which it really means that we really need this appropriate digital interfaces to allow this fast plug and play options, as well as possibility to really have cloud-based solutions and services. So of course we have the OCPP 1.6, as for the chargers, but also OPC UA is the local interface that allows to be able to let the chargers connected to these more traditional assets like batteries, solar, transformers, substation, and so on. And of course, this is how you can really reduce your energy costs, without impacting operations. Okay, so one example that we are working on now at the moment, as with this Porsche Taycan in emerging and overseas markets. So we're working with them to be able to provide, especially in as you see in some of the areas, not only in Europe and US, but to really work with them to come up with how ABB can provide some of these very high power, 350 kW chargers, which allow 200 kilometers in 8 minutes, but working with them and other, partners to be able to also serve them. Yeah, to also place them in the right place, so that this, power is available as, this car and also other future cars, would need this really, really high power for charging. Okay, so what does it mean in your city? As you see here, which means that you really need different type of charging solutions. It's not like one solution that works everywhere. So if you go from here, from the house side, from the apartments and workplace, which is called the destination charging, to really commercial fleets, which could be, these Amazon or FedEx type delivery trucks, to the so through the in-route charging for the buses, then overnight charging at the bus depots. Then you will have this public or commercial, like at your shopping stores, like IKEA and others. Then you have the single home residential charging, as well as fast charging roadside stations, where you really need this highway type of charging, but also in many of the public places. So as you see, so there's so many different type of charging solutions that are needed, as well as the one for the industrial fleets, right? If you're an industry and you want all of your fleet to be electrified. So on a site level, as was shown earlier, so it means it's not only the EV charging part, but also you really need to understand your power distribution infrastructure. In many of these cases, you need more and more of the batteries, and also you want to have these prefabricated and integrated solutions, which are like cookie cutter type of solutions, which you can just drop, so you don't have to spend a lot of time in the installation and so on. And above all, you really need this intelligent asset management, as was shown in the previous example, so that one has the control over the local power demand, as well as for the right connection to the grid.
Excuse me, Waqas, you have a next 5 minutes here.
Okay, sure. Okay, so as you see here, so based on these different things that we were showing, so there is AC chargers that are about 3 to 20 kilowatt, the DC destination charging 20 to 50 kilowatt. Then we have DC fast charging 50 to 180 kilowatt, and this is the area that is really growing now. Here also, that is part of many government subsidies and plans. And then you have the really high power, the DC high power, which is really at the highway gas stations in rural areas and sometimes also in the public charging, right? So now we move to another topic, the bus or the public transport. Okay, this is some examples where what we have delivered. Also, as you see, also in Indonesia, we have delivered some solutions. Okay, this is a case which shows some of these Singapore solutions with autonomous connection as well as some connection here in Perth. And what are the challenges here for a bus depot and so on? So this is really load management end to end. So as you see in a typical station where, okay, you may have dimension for a 5% of your buses, to be charged at the same time. You may be talking about okay, a certain level of the batteries that may be needed to be able to charge them. But of course, as the load for these buses will go to 100%, so you see you need even more batteries. So this allows your scalability, that as your buses or your electrification of your bus fleets grows, so you can still play in a modular way, where if you have constraints on the grid side, you can still play with the batteries, for example, and plan accordingly. But you really need this load management so that you have the power that is available. The other challenge here is really the integration of multiple bus chargers. They have to be in close proximity. They need to work in many cases autonomously with the pento up or pento down, this type of pantograph approach. But which means that they have to work in relation to each other. So this is another case where with the customer here, as you see here, there's so many of these autonomous pantographs, as you see here, very close to each other, which means that one has to have a mechanism, so how they're working at different buses at the same time. So not as individual connection points, but also together with each other, so that autonomous action is happening, but also the power that is needed from these guys is also synced, and then you don't have extra burden on your grid or your supply. And lastly is the interoperability challenges, which means so this is our lab here in Delft, where we can bring in all the entire buses and trucks and so on. So it's really how to work with all these partners, with the car and bus OEMs and so on, and to really make sure that the software on the vehicle side works with the software on the charger side, as you see here in the picture. Of course, it means that there's some consultants involved. We have to make sure that all the different type of chargers work with these guys, and also some testing and whatever is needed. at the bus station depots and the bus stops and so on to be able to also allow more driving range for the same type of batteries if you know how they're charged and the routes of these buses and so on is predicted. So interoperability is a key thing. We have been working with many of these players since 2010 when we were the founding member of CHAdeMO, where we were involved, and since then, as you see here, with all the different type of standards and really going to really high voltage 1000-volt type of solutions now. Okay, so I move to the last topic, sustainability. As mentioned at start, so this transportation is really 24% of the emissions today worldwide, and from ABB side, we have really committing to how to help reduce these. So this is the commitment that we are making, to the world. ABB as a company, that we are targeting a certain number of reduction in the from carbon. And as you see here, so it's not only related to electricity but also fleets. So we are also going to try to convert our own fleets to electrical. But also, many other things that we're trying to reduce. And one of the key players here to reduce this carbon footprint pledge from the company is really EV charging. So with the help of EV charging, we really have reduced customer emissions. So we believe we are really contributing in the right direction to the world that we all would like to have. In addition to what we are doing on the drives, the robotics, and also on the marine side.
Okay. Thank you, Waqas. I think your time is up. I think you can continue later with during question and answer. Maybe you can explain.
Okay, so this was my last slide anyway. Yeah.
Okay. Thank you.